In this module, we'll learn how to manage the lifecycle of the VMs using Ansible and OpenShift Virtualization collection. We'll focus on essential VM operations, including starting, stopping, and restarting virtual machines. To save time, I've updated the required code, but we'll go through each YAML file to understand what is happening. We'll start with updating the main.yaml file from within VM management role to invoke the appropriate task based on the action value defined in the Ansible playbook that we'll see next. Roles are a key component of RBAC in Ansible. They define what actions a user can perform on specific resources. This setup allows a single playbook to handle all three VM management tasks dynamically depending on the specified action. The task_file variable will trigger the specific playbook that we want to run as an Ansible job. The task will wait until a VM is stopped. This task will be included in the VM management role in the file named stop_vm.yaml. Later in the lab, we'll call this task from an Ansible playbook to demonstrate its capability. So let's break it down. The KubeBoot VM module that is part of the Red Hat OpenShift Virtualization collection is used to modify a VM behavior. The name parameter uses a user-defined variable called VM_name to specify which VM to stop. The run strategy equals halted ensures the VM is not running. The wait equals true ensures that the next Ansible task isn't triggered until the VM is completely stopped. After the changes are complete, we push the code to the Git repo, and then from within Ansible, we will sync the project which sources the playbook from this repo. Now that the project is synced, we can create new job template to trigger the VM stop action. We'll choose the inventory which contains the VMs that we imported in the previous module. We'll choose the playbook from VM management. Again, we'll use the pre-configured day 2 execution environment and OpenShift credentials. Here we'll specify the playbook variables now. We'll specify the name of the VM to stop, the namespace that it belongs to, and a specific VM task which will trigger the VM action. Let's launch the job and see the results. After it's complete, let's see the VM state in OpenShift. While the ability to manage specific VM is important, the real value of automation lies in managing multiple VMs at scale. In this section, we'll extend the functionality of the stop VM YAML file to handle all the virtual machines that reside within the namespace. Let's head back to the VS Code and create a new task to stop all VMs. Here as step 1, we'll retrieve the names of all VMs in the namespace in our OpenShift cluster. We're using KubeBoot VM info module for that. We then debug the VM info variable which has the metadata for all VMs in the namespace. This helps us in the next step to get the names of the VMs and namespace and use that to loop around all VMs and trigger a VM stop action. For each VM, we'll again wait till that VM is completely stopped before moving to the next VM. Let's head to Ansible and create a new job to stop all the VMs. Like before, I've created a new job template, but this time we'll only provide namespace and task named in the extra variable and will not provide the VM name. After the job is successfully completed, we can check the status of all the VMs in OpenShift, and as expected, they're all stopped. Now let's build on our knowledge of managing multiple VMs by creating a couple of additional tasks. The first one is to start all VMs. It's similar to what we did before, with only the change in run strategy, which is now always. That means that the VM would be running all the time. The second one is to restart all VMs, which is basically a combination of stop and start tasks that we had previously. Again, to speed things up, I've already created additional job templates. Let's start with the start all VMs job, and we'll provide the correct task name to execute. All the VMs are currently stopped as a result of the previous action. Now that this job is complete, the VMs are all in a running state. Now let's launch the other job, the restart all VMs. And if you look closely, you'll see all the VMs getting stopped first one by one, and then they get started.